So let's solve one more question on initial conditions. So as I said earlier on, the constant of integration C may be of interest in some applications, right? And in such cases, you may be specify a point that is a solution of the antiderivative or the integration that you are doing. Thereby, it will allow you to solve for the value of C. So such question mostly contains initial conditions, right? And these are the initial conditions which are going to help you to calculate for the value of C, and from there you get the original function back and you can use the original function to solve whatever further questions that you are going to be asked. So this is one example that I want us to solve before we proceed to the next subtopic. And this is the question. It was taken from the past calculus as well. It's one of the unsolved questions. So let's try and then analyze it here. So to kick off, let me read the question. A baseball is thrown directly upward with an initial velocity of 75 feet per second from an initial height of 30 feet. The velocity of the baseball is given by the function v of t equal to negative 32t plus 75, where t is the number of seconds since the ball was released and v is in feet per second. Find the function h that gives the height of the baseball after t seconds, using the fact that at t equal to 0, the ball is 30 feet above the ground. The B, what are the heights and the velocity of the baseball after 2 seconds of flight? C, after how many seconds does the ball reach its highest point? And a hint has been given. And in the D, how high does the ball get at its highest point? The E, after how many seconds will the ball hit the ground? And the last one is, what is the ball's velocity at the moment it hits the ground? So let's move on and analyze this question. So first of all, let's take our function, and our function here is v of t. So the velocity is a function of t, which is equal to negative 32t plus 75. Now, they are telling us that t is the number of seconds, so we know t is in seconds. So let's go ahead and also deduce some initial conditions from the question. So as you can see over here, the initial velocity, so they said the initial velocity was 75 feet per second, right? That's the initial velocity. You can see maybe v1 or v initial can be that. And then from an initial height, that's the initial height, maybe h initial, you can see that h initial equal to 30 feet. It's also here. So now the question is A, find the function h that gives the height in feet of t equal to 0. The ball is 30 feet above the ground. It means that at t equal to 0, h equal to what? 30. And when you look at the function, we have our v equal to negative 32t plus 75. So as I told you the other time, I told you that this is how the trend moves from distance or from height to velocity to acceleration. We differentiate. And then from the other way around, from maybe acceleration to velocity and then to height or the distance, we integrate. And at this stage, the velocity has been given and you are being asked to find the height, right? Find the function h, and therefore what we are going to do is to integrate the velocity. So if we have our velocity v equal to negative 32t plus 75. Then we need to do the integration over here. And this is one function, so when I integrate it, what am I going to get? When you integrate velocity, you are going to get height, which is h, and is equal to, now you have to integrate this function, and then I know you are now capable of integrating such functions. And integrating this function, this is how we do it. We get negative 32 t1 plus 1 over 1 plus 1 plus 75t, integration of a constant, and do not forget plus c. So now to simplify it, we have your h equal to negative 16, because here will be 2, and then t squared plus 75t plus c. So this is our function, which is a general solution to the question. This is a general solution to the question. Now let's look back and see what our initial condition is telling us. So the initial condition is telling us that at t equal to 0, our height is equal to 30, which is coming from this place. No, this place, yes, this is coming from this place. So you can see from there. So at t equal to 0, our height is 30. Therefore, 30 equal to negative 16 0 squared plus 75 0 plus c. And therefore, our 30 equal to what? C. Therefore, our function is going to be h equal to negative 16t squared plus 75t plus 30. So this is for A. This is for our A. Now we are done with the A. Now let's go to the B. The A was telling us to find the function h that gives the height of the baseball for after t seconds, using the fact that at t equal to 0, the ball is 30. So the B is also asking us, what are the height and the velocity of the baseball after t seconds? The velocity of the baseball after t seconds of flight. Now, this is our height, and therefore after 2 seconds, which means that t equal to 2 seconds. That's the B. At t equal to 2 seconds, we can say our height is equal to h equal to negative 16 multiplied by t squared plus 75 multiplied by 2 plus 30, which is our C. So now let's go to our calculator and use that one from there. So this is my calculator over here. So let me try something and see how things go. Oh, my calculator is not coming. So negative, looking at the calculator, negative 16 multiplied by into brackets 2 squared into bracket 2 squared, and then plus 75 also times 2 plus 30, and we have our final result to be 116 meters. So in this case, let's say we were given the height to be in feet, so 116 feet. So this is what I'm getting from my calculator. So now we are done with the part of the b. So let's look at the velocity. So they said we should find the velocity and then the height. So we are done with the height. Let's go to the velocity. So basically the velocity is equal to negative 32t plus 75, and therefore at t equal to 2 seconds, at 2 seconds we are going to have our velocity to be v equal to negative 32 times 2 plus 75. So let's go back to our calculator again and see how we can type it here. My calculator is not giving me. So negative 32 multiplied by 2 and then plus 75 will give us 11. So now high velocity equal to what? 11 feet per second. So let's go to the C. After how many seconds does the ball reach its heights or its highest point? And we have been given a hint that the ball stops for a moment before starting its downward fall. So at the highest point, the final velocity v is equal to 0. Just take note, at the highest point of a projectile, where the projector or any other object that you thrown above will stop a while and then come down. At that point, the velocity is actually 0, and therefore we can say that 0 is equal to negative 32t plus 75, and therefore making t the subject, we are going to get t equal to 75 times negative 75 over negative 32, of which will cancel out, and therefore our t, and then we can also use the calculator back again, and then that means 75 divided by, let me do the division first. So 75 divided by 32, and we are going to get 2.343, yes, 2.3437 seconds. So that's the answer for C. So let's go and look at the D. How high does the ball get at its highest point? So how high? That means that the ball reached the highest or the maximum point at the time t equal to 2.3437 seconds. And therefore we have our height h equal to negative 16t squared plus 75t plus 30. So how high the ball reached the highest point? Therefore you substitute the value of this t into the function h, and whatever you get will be the heights it got, or the maximum height that the ball reached, and therefore you are going to get negative 16 2.3437 squared plus 75 2.3437 plus 30, and we can do that using our calculator up there. If you want to use it, you can use it. So 75 over 32 all squared, and then plus 75 multiplied by 75 over 32, and then plus 30, and then use your calculator to confirm your answer, and let's see the final result. And then at the end of the day, you are going to get 117.89 feet. So h equal to 117.89 feet. So please use your calculator and confirm this answer. So let's look at the E. After how many seconds would the ball hit the ground? After how many seconds would the ball hit the ground? So that's the E. So they want the time that the ball hits the ground. And I know you agree with me that when the ball hits the ground, the height will be what? 0. When the ball hits the ground, the height will be 0, and therefore taking the function h equal to negative 16t squared plus 75t plus 30, h becomes 0. So now we have negative 16t squared plus 75t plus 30 should give us 0, and this becomes a quadratic equation. So these two, you pick your calculator, you type it negative 16, 75, and then 30, and then you get me your final results. So you will get two answers. One will be positive, one will be negative, and no, you don't have a negative time, so you pick the positive one, and therefore the time at which the ball will reach the ground, or when the ball hit the ground, it's 5.058 seconds. And let's look at the last one. The last one also talks about what is the ball's velocity at the moment it hits the ground. So at the moment it hits the ground, the time that it took to hit the ground, it's 5.058, and therefore at the moment it hits the ground, what will be the velocity? So you will get there, these are velocity function, v equal to negative 32t plus 75 and therefore at the moment, that's the question said, at the moment it hits the ground, what is the ball's velocity? At the moment it hits the ground, the initial velocity is 0, but it has a final velocity, and therefore my v equal to negative 32t multiplied by the 5, the time it took for the ball to hit the ground, 0.58 plus 75, and therefore v equal to, then you take your calculator, negative 32. So you pick your calculator and then confirm the answer. Negative 32 times 5.058 plus 75, and then you confirm the answer for us. That will be 86.856, and then the velocity will be 0 because it was actually decelerating down. Then the velocity will be negative because it's actually decelerating. So I don't want to attach it, so you can say that the ball was decelerating at the rate of 86.856 feet per second. So thank you for watching, and see you in my next video.